It's really hard to describe what overfitting is on paper, which is why I wanted to make this video using visuals and Python. So basically, overfitting is like this graph where AI will memorize the answer. As you can see, basically, overfitting, many people know what it is, but they may call it by different names. So some people will call it the bias trait variance. Doctors will often call it overinterpretation, model hallucination, or false positives. Basically, the data doesn't generalize or overtrains, like my engineering friend said. So most people know what it is or have a pretty good idea. They just don't know. These might be different terminology, which is also important to realize that a lot of people actually do know what it is, but you just have to use the right words. So as we can see in this, that the data was memorized, and when you try to actually use test data, it falls off. It's not going to be accurate. Using Python, I'm going to use decision trees using Titanic data. And this is what Python will see when you don't have data that is fit. So I just switched this to none. So it's not going to have a max depth for the tree. And when we show the data, basically, when it graphs it, it's going to look with a lot of trees. You're not even going to be able to read it. This is what it's going to look like when it's none. I'm going to do it one more time. So basically, when you have none, it has 100% accuracy, and this is what the data will look like right here. It thinks, oh, I memorized the data with 100% accuracy, and because there's no depth that's tuned, you can't even read this. It's uninterpretable. Basically, when you tune it to be 3, this is what it's going to look like now. And you can clearly see in this that gender and age played a huge part on if someone survived the Titanic data. And the accuracy gap goes down. So going back up here, I'm going to tune this manually. Normally you would automate this, potentially. But if you have 10 depth trees, the accuracy goes down to 0.12. Before it was 0.28, which is really high. And when you have 5 depth trees, it goes down to 0.6. And as we can see, you can start to see that it becomes more readable. It's less just scattered. And when you do 3, like we showed earlier, the accuracy goes down to 0.05. So this is going to get closer and closer to 0 as you tune the model better. And this is just one parameter for max depth. There's, especially for decision trees. There's other parameters too, many of them that you can tune. And as your data gets closer to 0, it becomes less overfit. And then that's when you score high on Kaggle competitions. And this is basically when you graph it through just a graph. Generally, and another thing to realize too is as there's more data, oftentimes the data will become easier to interpret for this. This wasn't the greatest example, but I will show you this. So 3 years ago, I scored top 5% using XGBoost and random forest and tuning it, and I'm going to make a separate video for that. So basically, as you start getting a more accurate model, you realize that high accuracy does not guarantee a good result. It has to be tuned to be realistic. Anyway, that's just overfitting in a few minutes using Python and data visualization. And I try to do as simple as I could. If you have any questions, leave a comment and I will answer. Thanks. Bye.